All right, today, guys, we're talking about graphing linear equalities. So it's similar to graphing equations, but we need to know if the line is dashed or solid and which direction we need to shade, right? Because an inequality isn't it equals this number. It's either greater than or equal to, less than or equal to, or less than this number. So there's a range of correct answers. It's not just one right answer. There's lots of right answers, right? And when there's no or equal to, well, that means it's a dashed line, right? Because the line itself is not correct. Everything right up to the line, but not the line itself. So if it's got the or equal to, well, then I know it's a solid line. Well, if it's less than or equal to, we shade below, right? Less than is below. That makes sense, right? And greater than is above, right? As I go above, my lines get greater. So the graphing part, right, we still find the y-intercept and use the slope to find our other points. So this y-intercept is +1, so start at +1, and my slope is 2. So I go up 2 over 1, up 2 over 1, right? I usually like to do at least 3 dots. All right, so now let's do the same thing we started with. Start the y-intercept, use the slope to find the other points. All right, up 2 over 1 again. But since this is just greater than, since it's not or equal to, it needs to be a dashed line. So I just got to leave little spaces. It's not a solid line because the line itself is not correct, right? But if it's greater than, right? Y is greater than, I need to shade above my line. And some of us get confused on which way is above or below. Some lines are easy. Obviously, we should hope. But always look at the y-intercept. Where is above the y-intercept? Above the y-intercept is this way. So that means all of this is my solution set. All of these points would make this equation true. All right, let's pick a random point. This point right here is 1, 7, right? 1, 7. Well, 2 times 1 plus 1, right? And my y number is 7. Well, 2 times 1 is 2. 2 plus 1 is 3. 7 is greater than 3. Well, yeah, that works. So I pick some random spot over here. This is -7, 4. So I plug in my y value is 4 is greater than. Well, 2 times -7 is -14 plus 1. Well, yeah, 4 is greater than -13. Yeah, so all of these points make this inequality true. All right, so again, it was dashed and it's greater than, so we shade above our line. Let's do one over here. All right, we do another example on this side. So we start at our y-intercept, -4. My slope is 2/3. So I go up 2 over 3, up 2 over 3. Well, this time it's less than or equal to. If it's got the or equal to, well then, all right, I know it's a solid line. All right, solid line. And it's less than. Well, less than is going to be below our line. So again, find our y-intercept. Below my y-intercept is this way. So all of this is my solution set. Right? Because all these points are below this line. Let's pick a random spot right here. Is 7, -4. I'm picking a lot of sevens. All right. Let's plug these values in. I'm going to pick the one beside it, actually. I'm going to do -6, 4, or 6, -4. Just because my denominator is 3, that'll be pretty. So my y value is -4, is less than or equal to, if I plug in 6 for 2/3, all right, so 6 times 2 is 12, divided by 3 is 4. And 4 minus 4 is 0. Yeah, -4 is less than or equal to 0. Well, yeah, that works. So all of these are correct. Right? These are all solutions to our inequality. So I want you to pause the video and you do these other 4 graphs down here. All right. And then when you're done, I'm have you check with your neighbors, make sure graphs look the same. And if you have time, check with your instructor. So pause the video right now and finish this side. Then we'll talk about the other side in a second. All right, so hopefully you did good on the linear inequality sign. Well, now we're doing a system of linear inequalities, right? So we got a graph both inequalities and find the shaded region where they overlap, right? Because I don't just have one inequality, I got two things happening. So the solutions are the points that make both inequalities true. So I still start with, I guess you got to do one line at a time. All right, my first one, my y-intercept is +1, and my slope is 2. Up 2 over 1, up 2 over 1, up 2 over 1. And it's got the or equal to, so then I know it's a solid line. And it's greater than. Well, greater than is above. So here's my y-intercept. Above my y-intercept is up here. So this whole side is shaded. All right. Well, now I got another line. I don't just have one inequality. I have a system. I have multiple inequalities. So this one, we start at +6 is our y-intercept. And our slope is -3. As soon as we go down 3 over 1, down 3 over 1, down 3 over 1. All right. And again, it's got the or equal to, so then I know it's a solid line. So this one's also a solid line. Okay. But now it's less than. So less than this line. So again, find my y-intercept. Well, less than this number is going to be down here. So all of this part is less than this line. So our solution set is the area where both of our shadings overlap. Like down here in this section, well, this makes our second inequality true, but not our first. And up here in this section makes the first inequality true, but not the second. And this over here makes nothing true. But this part, all right here, is where they both are shaded. So any random point, let's pick a random point right here. That is -4, 1. So let's plug those values in. All right, so I plugged this in the top one with my original color. My y value is 1, is greater than or equal to 2 times -4, which is -8 plus 1. Well, yeah, -8 plus 1 is -7, and 1 is greater than or equal to -7. Yeah, that works. So let's try it in this one. My y value is 1, is less than or equal to -3 times my x value, which is 12. 12 plus 6 is 18. Yeah, 1 is less than or equal to 18. So this is the correct region, because some random point in this region makes both inequalities true. So then I know that's the right shaded region, right? If I pick just a point down here, well, it's going to make this one true, but not the other one. Let's try it. Let's say I want to do 1, -2. All right, my y value is -2. Is less than or equal to -3 times 1 is -3 plus 6. Well, yeah, -2 is less than 3. That works, but it should not make this one true. Let's check. My y value is -2. I'm running out of space. So -2 is greater than or equal to 2 times 1 is 2 plus 1 is 3. Well, -2 is not greater than or equal to 3. Well, that's why this is not where the green line's shaded, because this is not a solution to our green line, right? So everywhere they overlap makes both inequalities true. So I can check it that way. Let's do one more. All right. So now we're looking at, sorry, all my stuff's kind of getting, so here's our, where we're focused. So again, my y-intercept is -4. So start at -4. And my slope is just 1, right? Because how many x's do you see? 1. So I show up 1 over 1. Okay. And it's got the or equal to, sorry, it's got the or equal to, so I know it's a solid line. So now, greater than x minus 4. So greater than is above. So again, find my y-intercept. Well, greater than -4 is this way, where my y, right? We go up for greater than. So that means all of this area is where they overlap. Well, not where they overlap. Sorry, is a solution to our first inequality. So let's look at our second one. So I start at positive 2 is my y-intercept. And it's negative 1/2. So I go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. You notice this one's not or equal to. So this one should be a dashed line. All right. Dash, 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 dash. Dash, 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 dash. Okay, so it's dashed. And it's greater than. So again, it's above my line. So here's my y-intercept. Well, above my y-intercept is going to be this way. So everywhere they're both shaded are my solution set for both. So my solution set is this area up here. So it's where the green and the purple overlap. This area makes the purple true, but not the green. This area makes the green true, but not the purple. And this makes neither one true. But let's talk about like this point right here, right? This is not a solution. And some of you are like, but it's where they overlap. Well, but look, this is on my purple line. Well, if it's a dashed line, well, then that's not a solution. Right? If I plug in, this is 0, 2. All right, so it makes this one true. 2 is greater than or equal to 0 minus 4. Well, that's negative 4. Yeah, that works. If I plug it into this one, 2 is greater than negative 1/2 times 0, 0, then 2. Well, 2 is not greater than 2, right? They're equal, but it's not or equal to. So if it's on a dashed line, that is not a solution, right? Above the dashed line is great because that's where they overlap. Or if it's on the solid line, that makes both the inequalities true. But if it's on a dashed line, it's not a solution, right? So those are just some little things we need to be aware of and to look for that make our life easier. All right, guys, I want you to finish this side. Again, check with your partner, your table mates. And then if you have time, please check with your instructor. Have a great day, guys.